This is Radhika. I am going to give a video lecture on power electronics. In this, today I am going to discuss about thyristor family devices. In last class, I discussed about the total thyristor family of devices, that are the 15 devices. Today we are going to discuss under thyristor family, that is the um, construction and two transistor analogy. So in this last topics are thyristor family devices, symbols of various thyristor family devices, and construction details of thyristors. Now today objects are constructional details of SCR, operation of SCR, two transistor analogy, and VI characteristics. So these are the mainly two topics we are going to discuss today. So in this, under construction of SCR, so the SCR is the silicon controlled rectifier, is the heart of the power electronic subject. So in this, the construction of SCR is, so this is the diagram of SCR. It has the 4-layer PNP and it has the 3 junctions. So actually the construction is SCR. Actually SCR is one of the most important type of power semiconductor device. So it is a 4-layer, 3 PNP junction and 3 terminal, means anode, cathode and gate device. So already in last class we discussed in symbols. So each and every thyristor, in thyristor family, each and every device has 4-layer and 3 junctions. 4 layers means PN, PN, and it has the 3 junction J1, J2 and J3, and it has the 3 terminals anode, cathode and gate. So anode is the positive terminal, cathode is the negative terminal, and gate terminal is the the signal will be applied to gate terminal. So in this diagram, the general connection of SCR, the 3 junctions J1, J2 and J3 are forward from the 4 layers of alternate P-type and N-type. So in this it has the P-type, N-type, P-type and N-type. So here it is the silicon semiconductor. This is the silicon semiconductor devices. So the threaded portion is provided for the purpose of tightening thyristor to the frame. So in this threaded stud is here. The threaded portion the threaded portion is provided for the purpose of tightening the thyristor to the frame or heat sink with the help of a nut. So gate terminal is kept near the cathode. So in the here it is the gate terminal. The gate terminal will be connected to the near to cathode terminal. So here, so in this it has the gate terminal welded to P region and cathode of aluminum terminal. So it has the anode, cathode and gate. So and also in this diagram, so these are the construction of SCR. So here, so in this figure, it has the terminal connected to outer P type. So in this, first of all, in this diagram, the layer is P type, N type, P type and N type. So here, so in this the terminal connected to outer P type, means first anode is connected to outer P type material, so that is called as anode, and the terminal connected to outer N type, so N type is called cathode, that is K, and the terminal connected to inner P region called gate, so PNPN. So where the inner P region terminal is called gate terminal. So the symbol that shows the symbol used for SCR. So this is already we discussed in last class. It has the three terminal, anode, cathode and gate. So here, so in this, so here, so in this, it has the symbol, SCR symbol. It has a three terminal, anode, cathode and gate. So here, the symbol used for SCR. The symbol used for SCR, as the SCRs are solid state devices, they are compact, possess high reliability and have low loss. So because of these features of SCRs are almost universally employed for all high power control devices. So in SCR is an unidirectional device, that is it blocks the low value of current from anode to cathode until it is triggered by the gate. So the gate terminal is triggered with pulses, but by proper triggering the gate terminal by proper gate signal between gate and cathode. So the signal will be applied in between gate and cathode terminal. The SCR will conduct the current from anode to cathode. Hence, the SCR is used as a controlled switch. Means the power electronics devices are used for controlling or conversion purpose. Controlling or conversion purpose means these are converts AC to DC or DC to AC, and also it controls means it works as a switch on off. So hence the SCR used a controlled switch to perform various functions such as rectification, inversion and regulation of power flow. So this is the normally construction of SCR. So these are the few main topics of construction of SCR. SCR is a 4-layer 3-terminal PN junction diode, and the outer P region is called anode and outer N region is called cathode and inner P region is called gate. So these are the 3 terminals connected to the particularly semiconductor devices, so semiconductor materials, and this is the 2 transistor analogy. So in this, so mainly this the SCR also works using of the 2 transistor analogy. Mean the each and every SCR has the four layers PN, and the transistors have the 3 types PNP or NPN. So in this, as in figure, the figure shows the PNP and NPN. These are the 2 transistors, mean one SCR, and it used in 2 transistors. So the operation of thyristor can be explained with the use of 2 transistor model. So this is the 2 transistor analogy model. This diagram is the 2 transistor analogy method. For 2 transistor model is obtained by bisecting the 2 middle layers. So in this, it has the red dotted lines. So the thyristor will be bisects in 2 portions, like as shown in dotted lines. So dotted lines, and it is separated in 2 halves. So the junctions J1 and J2 for PN line, J1, J2 and J2, J3 can be considered as PNP and NPN transistor respectively. So in this, it has the 3 lines, means, so in this it has the 3 junctions last. So these are the J1, J2, J3, like these 3 junctions. So here also they can divided the J1, J2, means it has the J1, J2 one junction and J2 and J3 second junction as PNP and NPN transistor. So the circuit representation of thyristor using PNP and NPN transistors. So this is the diagram of dotted line of schematic diagram of two analogy. So this is the two transistor analogy of SCR. Those are the PNP and NPN. So it is the given separate portion of the SCR portion. So here in this transistor T1 is the PNP and transistor T2 is the NPN. And also emitter E of transistor T1 is anode and emitter E of transistor 2 is cathode, and also gate G is positive with respect to cathode. And also during the half state of transistor, the collector current IC and emitter current IE is represented. Normally it has the few equations. So this is the total diagram, two transistor analogy of how the current will flow in circuit diagram to anode to finally cathode. In this diagram it has the anode in upwards, it is the anode, and this is the gate terminal and this is the cathode. So the current will flow from anode to cathode using of gate signals, gate pulse. So here is the junction again IC1 and this is the PNP and so this is the PNP transistor and this is the NPN transistor, two transistor. So combination is one SCR. So it has the IA current and finally IK current. Here the gate signal will be applied IG current. Okay, here this is the two transistor model how it will works. And in this during the off state of transistor, the collector current means IC is equal to alpha IE plus and ICBO, means here finally the current IC current means in this diagram is the collector current plus the gate signal. For giving the gate signal we have giving the IC current. So that's IC current is equal to alpha I current means emitter current and plus that is the ICB mean is the collector and base current. So here alpha is the common base current again and ICB is the common base leakage current for transistor 1. Only this IC current is for only transistor 1. So only for transistor 1, IC1 is the alpha 1 IE plus ICBO 1. Means the SCR in two transistor analogy, the common current IC collector current is alpha IE plus ICBO. So for transistor 1, it has the in this SCR it has the two transistor 1 and transistor 2. For transistor 1, the collector current IC1 is equal to alpha 1 of IE means emitter current plus ICBO means the collector base current. So here IC alpha is the common base current gain and ICBO is the common base leakage current. So and similarly the transistor I2 is the IC2 collector current IC2. Here IC1 and IC2 in this diagram is the IC1 and IC2. The IC1 current will flow to gate, means it is works as a signal for gate, and IC2 current is the collector current to NPN transistor. And finally the IC2 current is equal to alpha to IE emitter current plus ICBO2 means the current of collector and base current. So in this two transistor analogy of SCR is the total current IA is sum of collector currents of two transistors. So in this two transistor analogy, it has the two collector currents. So total current, anode current is IA is equal to IC1 plus IC2, collector 1 current and collector 2 current. So when gate is triggered, IK is equal to IA plus IG. Finally, the cathode current is equal to alpha 1 gate current plus ICBO, means is the collector and base current plus collector and base current of transistor 2, transistor 1 and transistor 2 currents by 1 minus alpha. So here is the 1 minus alpha 1 plus alpha 2. These are the current gains. So finally, in two transistor analogy, the cathode current is alpha 1 Ig plus current of common base current plus common base current of transistor 2 by 1 minus alpha 1 plus alpha 2. So before going to discuss another topic, just again this topic will be, we can listen in YouTube channel video also. So
next lecture series. Here in this session, I'll be going to explain two transistor analogy of SCR. In my previous session, I have explained structure and working of SCR. So we have already seen structure of SCR. Now I'll be going to explain two transistor analogy of SCR. So in previous session we have seen SCR is 4-layer 3-junction device. So here there is anode, here there is cathode, 3 junctions J1, J2 and J3 are there, and we have seen these layers are P, N, P, N, and third terminal of this SCR is gate. Now here we are deal with to see how we can have two transistor analogy of this device. So if I break this SCR from here, so I'll be having two part of SCR. One part is this, which is PNP, and second part is this, which is NPN. So that will act as a two transistors. So let us have this diagram first. So as I have told, this is what the one part which one can see, and that is what P and P, and second part of this is this, which is what I can say it is N, P, N. This terminal is anode, this terminal is cathode, and here there is a connection of gate. And this is what, just to understand analogy, otherwise this is what connected, so one can say this is connected like this. So that is how two transistor analogy is there, where this is what functioning like one transistor, which is what PNP transistor, and this portion that is functioning like NPN transistor. So let us try to make a circuit based on same, so that one can understand, like see how we can utilize this two transistor analogy. So here first let us draw a circuit and then we'll discuss how things are happening. So if I say this is what PNP, so I need to draw first transistor, which is PNP transistor. For PNP transistor, arrow will be in inward direction. So this is what PNP transistor, which is what I am drawing, and this terminal that is associated with anode, so I am connecting anode over here. Now this is what base, and this is collector, this is base and this is collector. Now another transistor, let us draw it first. So this is NPN transistor. So first I am drawing this NPN transistor and then we'll explain how connection is there. So this is NPN transistor as it is there over here, where this N that is associated with cathode. So here I can say this is what? Cathode, and this base that is there with P-type layer. So this base of this, that is what? Gate, that is associated like this, and collector of this first transistor that is connected with gate. One can see collector of this first transistor that is connected with gate. So that is what I have done over here. And base of first transistor that is connected with collector of second transistor. This is what? Base of first transistor that is connected with collector of second transistor. So here I need to connect this. So one can see equivalent circuit now. This is what equivalent circuit of SCR in terms of two transistor analogy. Now let us say this is transistor 1 and this is transistor 2. Now here I will be explaining this analogy in two aspects. So one aspect that one can clearly see over here, this is what SCR, where this is anode, this is cathode, and this is gate. Now here one can clearly see what is happening over here. Here anode current that is entering, let us say it is IA, and cathode current that is leaving, let us say it is IK. And if I say gate current that is inserted over here, that is IG. And as earlier we have discussed, based on gate current, this transistor could be triggered, and if transistor is getting triggered, anode to cathode current will flow and transistor will act as a switch. So switch operation that is purely based on controlling of gate current. So let us try to understand this analogy in this transistor analogy. So here one can clearly see this is what? Anode current which is happening and entering inside. Here I am inserting gate current, and this transistor Q2 that is leaving cathode current. Now let us try to understand current which is there inside of this transistor in terms of current with respect to transistor's notation. So if I say this is transistor Q1, so here current enters inside for PNP transistor, that will be IE1, and we are observing like say IE1 is equals to IA. And then over here current leaves to this collector, that is IC1. Over here current is IB1, and to second transistor this current is a collector current, so I will be saying like say this is what? IC2. IB1 and IC2 is equal, so one can clearly see IB1 and IC2 that is same, so I am saying like say this is what? E1 IB1. And the current which is getting inserted over here, that is IB1. And for this transistor current which is leaving, which is what? IE1. So that is how I am just right now giving a basic notations. Now if I say this transistor is having common base current gain, that is alpha 1, and for this transistor common base current gain is alpha 2. In that case, what will be IC1 and IC2 for these two transistor? So if common base current gain of Q1 and Q2 is alpha 1 and alpha 2, then IC1, that is equals to alpha 1 into IE1 plus reverse recovery current ICO1, and IC2, that is alpha 2 into IE2 plus reverse recovery current of transistor 2. So see, IC1 and IC2, those could be calculated based on current gain, common base current gain alpha 1 and alpha 2, that is having relevance in terms of IE1 and IE2. Now before I derive a basic analogy of SCR using two transistor analogy, let us try to understand what is our goal. Our goal is to have a derivation of anode current, and I want to see what will be anode current with respect to gate current and how it is internally functioning inside of transistor. So this is what the basic aim, which is what I am keeping in my mind. So what I want is, I want to derive anode current in terms of alpha 1 and alpha 2, and then we want to see how SCR is getting triggered. So I will be deriving anode current in terms of alpha 1 and alpha 2. So if I see this Q2 transistor, then from this Q2 transistor one can say, this is IB2 and this is IE2. So from this Q2 transistor one can say IE2 is equals to IC2 plus IB2. So from Q2 transistor one can say IE2 is equals to IC2 plus IB2. Now here if we see what is IB2, so IB2 as per this junction we can say IB2 is equals to IG plus IC1. Here at this junction entering current is IG and IC1 and leaving current is IB2. So IB2, that is equals to IC1 plus IG. So let us place it over here. So IE2, that is IC2 plus IB2 is IC1 plus IG. Now here one more thing that we know, IE2 is IK. IE2, that is IK. So IE2, that is equals to IK, and that is IC2 plus IC1 plus IG. Now we can clearly see from this SCR, IK, that is IA plus IG. IK, that is IA plus IG. So here I am placing this value only, IA plus IG, that is equals to IC2 plus IC1 plus IG. So here IG will get cancelled, and I'll be having IA, that is equals to IC2 plus IC1. Now I have anode current, which is what, IA is equals to IC2 plus IC1, and initially, as I have told you, IC1 current, that is alpha 1 plus IE1 plus reverse recovery current in transistor 1, which is what, ICO1, and IC2, that is equals to alpha 2 into IE2 plus ICO2, which is what, reverse recovery current in transistor 2. So let us place those values. So we'll be having IA, that is IC2 is alpha 2 IE2 plus ICO2 plus IC1, that is alpha 1 IE1 plus ICO1. Now here IE2, that is IK, as we have seen, and IK is IA plus IG. So let us place those value. So IA is equals to alpha 2 into IE2, that is IK, and IK is IA plus IG. And let us take this term first. So plus alpha 1 and IE1. So IE1, that already I have said, IE1 is IA. So alpha 1, that is IE1, that is IA plus ICO1 plus ICO2. So now let us make IA as a major term so that we can have equation in terms of IA. So IA into 1 minus, let us take this 2 term over this side, so it will be alpha 1 plus alpha 2 like this, and in this side we'll be having ICO1 plus ICO2 plus alpha 2 IG, right? So ultimately we'll be having a final formula of anode current, that is ICO1 plus ICO2 plus alpha 2 IG divided by 1 minus alpha 1 plus alpha 2. So this will be anode current, which is what we are having. Now how this anode current is important and how this transistor is functioning, SCR is functioning, as well as transistor analogy is functioning. So already we have discussed, like, as if I pass gate current, then this SCR will get trigger and anode to cathode current will flow. But how it will happen with respect to this equation? So what will happen, as if I pass gate current, this alpha 1 and alpha 2 addition, that will go towards unity. So what will happen, as IG increases, alpha 1 plus alpha 2 will go towards 1. So if alpha 1 plus alpha 2, that will go towards 1, this IA, that will increase. And if IA will increase, SCR will on. So see, ultimately, as if you increase IG, alpha 1 plus alpha 2, that will go towards 1, and as if this goes towards 1, IA will increase and that will trigger SCR. What will happen? As if alpha 1 plus alpha 2, that will go towards 1, IA increases, and if this IA increases above latching current, if IA increases above latching current, then SCR will get trigger. Now there should be a question like, why alpha 1 and alpha 2 will increase as if IG increases? So let us try to understand this, why that happens. So first of all, how alpha 1 and alpha 2, that depends on transistor. Let us try to understand that first. So I am just drawing transistor over here. One can take example of NPN or PNP, both are having same phenomenon. If I say I have PNP transistor, this is base, this is collector, and this is emitter. Now here value of alpha, that depends on base width, value of alpha that depends on width of base of transistor. So if base width is more, then alpha is more. So this is what the phenomenon which is there with this. So ultimately what will happen over here is, we need to focus about what will happen with respect to base width. So here in this two transistor analogy, as anode is positive with respect to cathode, J2 junction will be in reverse bias. This junction, that will be in reverse bias. So as if this junction is in reverse bias, its depletion width, that will increase. So as depletion width, that will increase, one can clearly see it will affect over here even for transistor 1, as well as it will affect over here for transistor 2. So what it does, it is decreasing width of base. So as I have told, sorry I have done mistake, as width is more, alpha is less. As width is more, alpha is less. So ultimately, as J2 junction is in reverse bias, as we increase anode voltage, depletion width will increase, and as depletion width of J2 junction increases, one can clearly see for this PNP transistor, base width is decreasing, and for this second NPN transistor, its base width is even decreasing. So what will happen with this transistor? This transistor is having alpha 1 and common base current gain is alpha 1, and this common base current gain, that will increase as depletion width increases. And for this second transistor, it is having common base current gain alpha 2, that will even increase. So what will happen, as we increase IG, junctions width increases, and junction width increase will result into increase in alpha 1 and alpha 2, and once it goes towards 1, IA current will increase, and once IA current increases, it will trigger SCR. So see, this is what the basic methodology which is there with two transistor analogy, and that is how one can understand how SCR is functioning with respect to two transistor analogy. Thank you so much for watching this video. If you understand this video, then please comment in.
So this is the video lecture for two transistor analogy in detailing. So next class I am going to discuss about the BI characteristics of SCR. Thank you.